Yeah, so I work for Historic Environment Scotland, and I'm going to present work in which I've been using airborne lidar data available for Scotland, for parts of Scotland, to identify whether we can see cropmark sites in that data. And this is work that is funded by the Royal Society of Edinburgh, and I have to mention it right here, right now. As we observe over the last few papers, but also over the last few decades, lidar has become almost a household item and a household device. So we can see the expansion of the data throughout the world, from Mesoamerica and Antarctica to Northern Europe and Southeast Asia. And of course, the magic of lidar is to identify earthworks, and we usually find earthworks in areas that are outside modern cultivation mostly, and in most of the successful applications of lidar have produced new sites identified in forest. So this is the primary use of airborne lidar data throughout the world to identify it in the forest. And of course, most of the lidar data penetrate. I mean, in certain conditions, lidar can penetrate the canopy and produce high-resolution digital terrain models of the surface under the forest. And because of that reason, most of the topographic data that has been collected throughout Europe has been collected over autumn or late winter conditions to minimize the negative impact of the foliage. So because of that, we get a better translucency of the canopy, and we can produce higher resolution models. And this refers not only to hydrology or other modeling, but also how we see archaeological sites and how they show themselves in lidar data. And this is an example from 5 different collection dates and how this affects the visibility of small-scale archaeological features in Austria. However, in agricultural land, which has been largely plowed, there are 3 types of sites that we can still identify in lidar data. So first type is we can still see earthworks that survive in pockets of land that has fallen outside modern cultivation, as it is in the case of this fork in 5. So we got a plot of land that has been excluded from cultivation, and it's no longer, the earthworks are no longer leveled in plow. The second type, we've got earthworks that are still surviving in the fields. So there are still very faint features which can still identify in high data. They are very shallow, they are very faint, and they are, of course, way more smooth than those features that are no longer cultivated. But finally, we've got sites which do not survive in an earthwork forest anymore. They have been completely leveled, and they are shown as crop marks, as soil marks, or all types of marks that we can see. And this is the site which I identified. We identified first, where we saw on the lidar visualization those 3 strips, most likely showing that we can observe crop marks in the high data, which wasn't really surprising, but I will guide you through what we can do with that data. So if we have I'm going to focus primarily on those level sites which show as crop. So in Scotland, we've got over 9,000 sites that are identified as crop marks, or they demonstrate a crop mark component. And they are scattered mostly along the east coast, but also in the central belt and in the southwest. And of course, they are outside the urban areas, and they are usually very close to the sea. Most of the sites will be within 10 kilometers from the sea, and not more than 50 meters above sea level. So this is the distribution of the sites that crop mark sites that we have recorded in Scotland. And at the same time, we've got airborne lidar data available for the country, which covers mostly the central belt and parts of the south. So lowland areas and some river valleys as well. And most of this data, to the contrary of what has been collected in other parts of Europe, has been collected over late spring and summertime. This is because it was collected for Scottish Power and all our other power distribution companies, which were not bothered about the vegetation and its impact on the topography, because what they were doing they were monitoring the grid. So this is the data that the Scottish government purchased off the shelf and added to the national portfolio. So we get about a third of the country's landmass covered. And I'm going to talk about four phases of data collection that I use the data for. And this is quite high resolution data. It's about 25 points per square meter. So producing really detailed terrain models, but collected between July, mostly between May and September. And as you can see, the distribution of those strips of data is uneven, and it's scattered throughout the country. And in different phases, in different years, in different parts of the country, of course, were collected, a pattern which we see all over Europe, but this has a crucial meaning for the analysis later. So if we have the data that's been collected over 4 or 5 years, as we know from most of us working in aerial archaeology, we know that crop marks do not show every year. They usually show when we get drier summers, where there is a higher soil moisture deficit levels, and so on. So over the last few years, when the airborne lidar data was collected between 2015 and 2021, we had 2 summers that were really good. The first one was 2018. As you can see, the really high level of soil moisture deficit values for Scotland in 2018, and also in 2020, but I don't have the data from Met Office to show you here. 2020 was the year when we didn't do much flying because of COVID, but this was the year where quite a bit of country has been covered with airborne lidar data, especially in days between June and August. So this is the data that I'm going to focus on, because in 2019, only very limited area has been covered with this data. So in the year where there were perfect conditions and there was cropmark bonanza, as it was mentioned here on the BBC, I believe, we don't have that much data available. So in total, if we have about 9,000 sites, this comes in 9,000 cropmark sites in Scotland. In July and August of 2020, for which there was a high soil moisture deficit levels, we come down to about 1,000 sites, 1,100 sites. So this is already a big chunk of data that we eliminated based on the weather pattern and climate condition. So the method to identify cropmark sites in lidar data has been investigated by a few teams, including a team of Dave Stott and the rest, who've been trying to identify in multi-temporal data the difference in height in crops, as it is in aerial archaeology, of course, in RGB and in passive surveying. But instead of using multi-temporal data, I was trying to identify whether we could see crop marks in a single data set collected in 2020. So for this site that has been identified in aerial imagery, you can see not only those drains and ditches here, but also those small pits here, and I will use those pits to show you, to demonstrate how the method behaves. And as you can see here, this is a digital surface model. It's a 25 centimeter pixel size here, and demonstrating, and we get a 3-dimensional hill shape on the left-hand side, and overlaid by a local relief model on the right-hand side. You can see not only that the bigger features, the drains, are showing quite clearly but you can really see the details of all of those bits that are scattered across the field, also the bigger pictures here. I could finish right now. It works. It works for this site. It will work most likely for other sites. Okay, but I try to see whether we can even enhance this data, if we can get something out of it more than what we can see here. Luckily, for parts of 5 where those cropmark sites that have been surveyed in 2020, we have also vertical imagery from the same year collected about 2 weeks later. So on the left-hand side, you've got the vertical imagery of the same site, which was collected about 2 weeks after lidar has been shown. So it's not a magic. I mean, it's a good year. We can see crop marks in aerial. We'll most likely see crop marks in lidar. It's not a rocket science, but do we actually see as much in the aerial imagery as we can see in lidar? Even if we do contrast enhancement on the aerial imagery, we can see that there are some differences between those two. But I decided, instead of comparing them separately, I decided to combine them and do some image fusion. And this is the result that I'm going to present you in other case studies here, where you can see almost the 3-dimensional crop marks showing and popping very crispy across the field. So not only those bits are really visible here, you can really see almost the shadow of the crop here, and you can see that this linear pattern feature actually continues here in the adjoining field, which you don't actually see in the field in aerial imagery. So there is benefit of using 3D data and combining it with the blue and green channel from the vertical imagery. So how does it show for the other sites? Well, it shows really well. Maybe not on a big screen in a bright room, but on a darker screen, it shows really good. So what we got not only a large patterning of weakened furrow cutting along this field, but also the small pits visible over here, as this is a pit-defined courses, and this is a zoom on those pits in this area. So we can actually identify, on the right-hand side, we've got the results of aerial photograph transcription from historical metropolitan records, and on the left-hand side, we've got the clear image without it. And even here, we can see the patterning of the weakened furrow. We can see the small features that are here, which have not been picked up, in previous transcriptions. So we can see more. We can see something different than we have seen before. And at the same time, we can start to do some detailed analysis of the crop marks. So we can actually calculate what's the difference in height, what's the difference between different textures. As you can see, compare those two images, you can see that the texture of the crop surrounding this light soil, where we can see the crop marks, is completely different, because this is a very smooth area with a very tight, very closely growing crop, and all the rest is very irregular, causing lots of noise in the high data, which we can also see in the RGB imagery. But this we can use to do some calculations. We can extract features like this in the high data using automated methods, for instance, and we can do more calculations about it. But of course, it's not everything is not so looking so good as it could seem, because in a different landscape we do not see. I mean, we can see major features, but some of the smaller size, which should appear in this part of the image, they do not show. So it's not that we are seeing every single crop mark. It's not that we are seeing every single ditch or earthwork, surviving. I mean, surviving as cropmark. There are pitfalls here which we need to avoid, and which includes also some data artifacts. And along this Roman fort in North 5, and there are some other features scattered throughout the field, you might be able to see this wavy pattern over here. And this wavy pattern is the strip, is this lidar data strip and edge. So there was a little bit of misalignment, creating this wavy feature, which is natural, and we do not observe it in the AP. Similarly here, I mean, if you are used to interpret lidar data, you will see this wavy pattern throughout different data sets. But over here, you'll also see a feature like here, which is natural either. It's also a data artifact coming from a single strip of data being slightly higher. It's a matter of few millimeters higher than what we have in the background, creating this additional lines which are not visible on the AP. And finally, my last example, it's a 3D data. And in the 3D data, it's in the high data, you will have also different kinds of noise. And this wavy pattern is actually a wind blowing through the fields of Scotland, which you cannot, of course, see in the other data. So, to conclude, it seems to be an effective method in recording crop marks, and we can use it on a large scale. And although it was about 1,000 sites that have been covered with the data at perfect conditions, of course, only about a quarter of them were was covered with winter-grown crops, which could produce crop marks at this moment of time, which is mid-August 2020, and it proves to be really successful when there is a data fusion with aerial satellite imagery collected more or less on the same period, which allows us to enhance which enhances our understanding of crop mark formation. And based on that, of course, looking forward, we could do some relative calibration of radiometric information, because right now I've only touched about the high data, but because LiDAR is using infrared signals, we can actually try to extract that information and merge it together with RGB imagery and high data. And of course, this allows us to, if we get this in the 3D data, it will be much easier to use it in machine learning and automation, because it takes away the colors, and instead we could use the high data instead. And of course, the large-scale assessment has been affected by the land use pattern, and there are some data artifacts there. And of course, as with aerial survey, classical aerial survey time and date is critical. So if there is a full wet year, just like this year, at least for us, north of the border, we won't see much. And the cost benefit, well, it's really useful because you can really enhance the record if you are using data that is more or less available for free. I mean, scanning this kind of area, scanning hundreds of square kilometers only to get crop mark data, this might not pay you back because of the land use pattern and how the crops develop and how patchy all these crop marks are. Of course, we can do this with structure from motion. We can do it with drones. We can do it with we can extract this kind of 3D information using passive sensors, but this data is available, it's for free. And if you got access to this, I would encourage you to explore it, because it allows you to look at the large scale and identify also new sites, which I haven't presented here, but there are many of them. Thank you.